Today we'll be solving question number 5th from GATE 2021 Mechanical Engineering Set 1. So this question is from Engineering Mathematics from the binomial distribution or the probability distribution you can say. So the question they have asked is like consider a binomial random variable x, and if x1, x2 so on to xn are independent and identically distributed samples from the distribution of x with some y equals to summation I equals to 1 to n xi, then the distribution of y as n tends to infinity can be approximated as first option they have given is exponential, second Bernoulli's, third is binomial distribution, and fourth is normal distribution. So before coming to the solution, let me just give you a quick concept of related to this probability distribution. So you might be very familiar with the game of cricket, right? So how do we decide who is going to bat or ball in a cricket, right? So it's by toss, obviously, right? So it all depends whether you win or lose the toss. So let's say if the toss results in a head, you win, or else you lose. So there is no midway. So here comes into picture the Bernoulli's distribution. So in this type of distribution, there is only this type of distribution comes into play when we have only two outcomes, right? First, this is the success or is the failure, and moreover, let me just highlight the main things. Yeah, and the main thing which plays a major role is it happens in a single trial, right? So the keywords which I am highlighting, you just keep an eye on it because it will be helpful when you will be solving the questions which will be asked in the gate, right? So the random variable x which has a Bernoulli distribution can take the value of the y and with the probability of success say p, and the value 0 with the probability of failure say q equals to 1 minus p. So in this case, the occurrence of head denotes the success and the occurrence of tail denotes the failure. So the probability of getting head equals to 0.5 because half is the probability either they will get one team will get head or another team will get the tail, right? So the probability of getting head is equal to the probability of getting a tail since there are only two possible outcomes, and it can be expressed as a 1 and 1 minus p, right? So the next type of distribution which plays a major role is the binomial distribution. So binomial distribution, let's again talk about the cricket. Like suppose you won the toss today, and this indicates a successful event. Okay, now you toss again, but you lost this time, right? So if you win a toss today, this does not it is not necessary that you will win the toss tomorrow again. So in this case, let's just assign the random variable cx to the total number of times you won the toss. So what can be the possible value of the x? So in that case, we use the binomial distribution. So there are some of the characteristics which I have highlighted out of this whole binomial distribution concept, so that because if tomorrow you will be getting some kind of the objective related to it, you can easily saw the characteristics related to the particular distribution and you easily mark off your question, right? If it comes in one mark. So in case of binomial distribution, each trial is independent, like I have discussed recently. So there are only two possible outcomes in a trial, either a success or a failure. The total number of the n identical trials are conducted, right? So there are finite number of the trials, finite I am talking about. Next, the probability of success and the failure is same for all the trials, like no matter how many times, 10 times, 20 times, 30 times you repeat, the probability of the success and the failure will be same, right? So the next type of the distribution which has been given in the option also is the normal distribution. So this distribution represents the behavior of most of the situations in the universe, right? So that is why it is called as the normal distribution. So the large sum of the random variables. So it what happens in case of the binomial distribution? There are some set of the discrete values. By discrete values, I mean to say, like if you roll a dice, so the probability you will be getting a number is like 1 2 3 4 5 6, right? But in this case of the normal distribution, the probability in case of the this normal distribution, what happens, like you can get any value within a specific range, like 55.2, 66.2 in measuring some weight, in measuring the height of some person, in measuring the length of any object, right? So in this case we have this discrete set of the values, and it has also some certain characteristics. And moreover the most important thing here in this case, the n tends to infinity, right? Because there are n number of the random variables which turns out to be normal distributed, right? So there are n number of the things which are happening, because that is why we are saying like it covers more situation in the universe. So in the universe is big, very big, right? So there are n number of things which is happening. So if we want to create some kind of the I mean if you want to plot something out of the things which are happening in the range of the infinity, because universe is infinity. So here, so in that case a normal distribution comes into picture. So there are some characteristic like the total area under the curve is 1, the mean mode and the median of the distribution coincide, and exactly half of the values are left to the center and to the which is equal to the other half to the right. Next is the exponential distribution. Exponential distribution is basically used for the, I mean, to check out the survival of any life, survival of any, I mean, of anything, or to I mean predict the interval happening between the interval in the event, interval happening in between the two events, right? Let us suppose if a metro is coming at 10 a.m., then it is coming at around 20 a.m., then it is coming at around 12:30 a.m., right? So exponentially we can calculate when the next metro is going to come, right? So in that case we use the exponential distribution. Just to expected life of the machine we can also calculate, or the expected life of a human also, right? So its major role plays with respect to the time, right? Like how much it has survived up to that particular time. So in that scenarios exponential distribution comes into picture. Then these are the basically, out of the whole concepts I have made this committee to memory to 1 2 points after every question I will be making, so that you don't have to go through the concepts every time, and you can go through these highlighted points, or the highlighted lines, so that you can during the last minutes of your exam, or during the last days of your before your exam, you can go through these I mean concepts, or one liners, and then you can easily, I mean, refresh your concepts through this, right? So it says Bernoulli deals with the outcome of a single trial of the event, like we have discussed, whereas the binomial deals with the outcome of the multiple trials. Now you got it. What is the difference between the Bernoulli's distribution and the binomial distribution? In case of the Bernoulli's distribution, although there are two cases like success or the failure, but it is happening with respect to the single trial of the event. But in case of the binomial distribution, it is happening with respect to the multiple trials of the single event, right? So in Bernoulli is used when the outcome of an event is required for only one time, whereas the binomial is used when the outcome of an event is required multiple times, right? So this is the difference between the Bernoulli and the binomial distribution. Now the main difference between the binomial and the normal distribution is that the binomial distribution is discrete, like I have said, whereas the normal distribution is the continuous, because there are some random values are there, right? So it means that the binomial distribution has a finite amount of the events, right? Whereas the normal distribution has infinite number of the events, which has infinite number of the events. So right, so now let's go back to the question what they have asked. So here in this case he is asking the distribution of y as n tends to, as n tends to, just a second, as n tends to infinity. So in this case infinity, he's talking about the number of infinite number of the trials. So we have seen that for the infinite number of the events, what is kind of distribution we do use to calculate? It is the normal distribution, right? So according to it, which is the correct answer? Normal distribution is the correct answer. Binomial will be, I mean, excluded out, because there are infinite number of the events. Bernoulli, here it is not a single trial is happening. Exponential, it is not calculating with respect to time. So only the normal option is correct. Right? Okay.